Welcome to MOVI-C Cabinet and Decentralized VFDs 201. This is session 12, using the scope number 1. So what's the number 1 about? Well, we're going to split this topic into two parts. It's a very big one. As I warned you last time, this is probably the most complex session in the class, so I hope you're ready. Let's dive in and get going. Now, this class isn't exactly another big drink. You've already had two of those. I like to think of it instead sort of like a giant burger. It's a lot of fun to eat, but it is big. Well, we're going to make the giant burger a little more manageable by cutting it in half. We're going to cover just half the scope in this session. We're going to do one lab. Then our next session will finish the scope and we'll do a second lab. Let's get into it. If you've ever used a laboratory bench oscilloscope before, you know what a wonderful tool it is. You can do many things with it. Well, there is a scope built into your VFD that works very much like a multi-channel bench oscilloscope. You can use it for a variety of things. For example, confirming that everything is working correctly. You can check that a ramp takes the amount of time you expect, for example. You can use it to optimize performance. In fact, we're going to be using it in this lab to tune our motor better. You can also use it for diagnostics where you're trying to identify abnormal behaviors. And this is a big one. You can use it to troubleshoot those difficult to find faults, the ones that happen only once a week, the ones that you can't figure out why they happen. You can set the scope up to watch for that fault, and it will wait for it if necessary for weeks. And when it finally comes, it will capture data that you can then use to figure out what's really going on. This is the scope that's available through MOVI-Suite. Although you use MOVI-Suite to display the data and to set up the scope really isn't in MOVI-Suite at all. It's built into the VFD. That means it can run continuously in the background without a PC connected to the VFD. You just use the PC to set it up, then you can unplug and walk away and come back later if necessary to collect the data. Very handy. The scope has two operating modes and they serve completely different purposes. We're going to cover both operating modes, but we're only going to cover the first one in this session. The modes are continuous trace mode. In this one, when you start the scope, you'll see the data appear on the screen immediately in real time, and it will just keep scrolling by. This mode is handy for confirming that everything is operating as you expect. Now, the second mode is called single trace mode. It's also known as triggered capture mode. In this mode, nothing appears on the screen. The scope simply sits and waits. It's waiting for an event called the trigger. When that event happens, it takes a snapshot of the data surrounding that event and displays it on the screen when you go to collect it. The event is represented by a white line somewhere down the screen. In this case, it's in the middle. The data before the white line is what occurred before the trigger, and the data after the white line is the data that came after the trigger. You can look at this information surrounding the trigger and it can give you insights into what's going on in the VFD. We'll be looking at single trace mode in our next session. How do you set the scope up? Well, our hamburger analogy is very appropriate here. It's actually like building a burger. If you go to one of those fancy burger bar restaurants where they give you the burger, but then you get to set it up and you build up all the layers. Well, setting the scope up is very similar to it, so I'm going to kind of use that burger metaphor as we go along. First of all, of course, we have to get the scope running. It actually runs as a separate tool in a separate window. You can launch it from two places. It doesn't matter which one. You can right-click on the top of the VFD circle and then pick Scope from the Tools menu. Or you can click the More menu in the upper right corner of MOVI-Suite and you can pick Scope from the Tools menu there. Doesn't matter, either one is the same thing. The scope will open up in a new window, and the first thing it's going to ask you to do is to either open up an existing project or create a new one. Scope projects are stored within your MOVI-Suite file, your project file that you save, in a virtual folder within that project. You won't find a folder on your hard drive on your SSD. It's inside the MOVI-Suite file, but it behaves like a folder. Now, if you've already created projects in there, you can go through that virtual folder and pick an existing project. But in this lab, since we haven't done that yet, we're going to create a brand new one. So we'll click Create. Now, the MOVI-Suite project can contain one or more scope projects inside the virtual scope folder, and each project can contain one or more traces. These are data collection runs, and you can have several traces in there. The important thing to remember is that scope projects can be exported to an external file, which can then be emailed to someone like a support engineer at SEW Eurodrive. Scope project management is handled by a window shade. Now, in this case, it's open automatically. You can see it's pulled down right there, but you will see it in the upper part of the screen most of the time, and you can always open it just by clicking it. And we're going to go ahead and start building our hamburger. And the way we do it is we work through these 4 tabs. These are the layers of the hamburger: the meat, the bun, the cheese, the condiments, the lettuce, and so forth. So we're going to start with measurement mode and then work our way through these different choices. And I want to warn you, never click the apply button until you're all finished. The apply button is sort of like saying, eat the hamburger. And of course, you never eat the hamburger until you finish building it. So we're in measurement mode. The first thing we have to do is give our trace a name. MOVI-Suite creates one automatically with a timestamp, which is fine, but you might want to change it to something more descriptive. And then you have to pick the measurement mode. Remember I said the scope has 2 modes, continuous and single trace? Well, this is the place where you pick the one you want to use. So you pick your mode. We'll pick continuous trace because that's what we're doing in this session. And then you move on to recording channel. That's the next layer. The scope has 10 different channels that can monitor a wide variety of VFD properties. You do not have to monitor 10 things at once unless you want to, but it's handy if you need to do that. You're picking what you want the scope to monitor and turn into traces. In this case, we have 3, and the others are set to no function. Each channel has a number, 1 through 10. It has a color. This will be the color of the trace when you look at it on screen. You have a show hide trace switch to turn a trace on or off. So if you want to turn something off temporarily, you can flip that off. The pull-down menus allow you to pick the property that channel is going to monitor. I'll show you how to set these up in just a minute. And then we have a description of the property and its units. And if you ever decide you want to get rid of a property and set a channel to no function, just click the reset button for that channel. Now, there are 4 different ways to select and assign a property to a channel. When you click the pull-down, you will see this box, and your first choice on this list of tabs is default selection. This is sort of like the I/O selection box you used back in the terminal control lab. You can pick from a list of the most common properties. In many cases, what you want will be right here, but if it's not, you can click the second tab, which gives you the master properties list. I warn you, there are hundreds of properties here, so this could take some time. I recommend you use method number 3 if you're using the master list. Use the search box and type in some text that narrows things down. And then the 4th way is kind of interesting. You can enter the property's index and subindex number to directly select it. Now you may wonder, what is an index and subindex? Well, you've actually been seeing them all the time if you've been working in MOVI-Suite. And if you've just been watching me, you've been seeing them all the time. You've probably noticed that if I leave the mouse pointer somewhere for a while and don't move it, a box will pop up. Now that box contains information about whatever it is the mouse pointer is resting on. Among that data is the index and subindex number of that object. So for example, let's say I want to monitor the rotational speed of my motor. I don't want to go through that master list and look for it. And I happen to be in MOVI-Suite, and I'm looking at a screen that shows the rotational speed right here. And I say, I want to scope that. What can I do? Well, I can simply hover over that spot for a second. Don't let the mouse move. And one of these little info boxes will pop up. And if you look right here where it says index, you will see a 4-digit number and then a 2-digit number following a decimal point. That is the index and subindex number of that particular property. And if I type those two numbers into the index and subindex box, the scope will monitor that particular property. Basically, almost anything in MOVI-Suite can be monitored, although in many cases some of them would be silly. So that's your fourth way to select a property. Now let's go on a little digression to talk about how the scope works, because I think if you understand what it's doing in the background, it's going to make a lot more sense to you. Think of the scope like a camera that can take a snapshot of each channel, each monitored property, and it stores those values in its memory. So our scope is the camera, the capture hardware, and in this case, we're going to monitor just four properties: motor speed, motor current, motor torque, and DC link. Those are very useful for diagnostics. But remember, you can monitor up to 10. The scope is going to store its snapshots in a memory buffer associated with each channel. Each channel has its own memory. When the scope starts up, it takes pictures of those channels at regular intervals, converts the data to a number, and stores it in its memory. And then later, when you come back with MOVI-Suite, it will turn those numbers into the graphs that you look at on the screen. Now, why do we care about this? It's very simple. The sample rate, which you set in MOVI-Suite, determines how often the scope takes the snapshots. The faster the sample rate, the better the quality of the trace, but of course the scope is going to fill its memory a lot faster. Setting the right sample rate is important. It's kind of the art form of using the scope, and experience will teach you what a good sample rate is and what a poor choice would be. We set the sample rate by selecting the Control tab. You notice, by the way, we've skipped the Trigger tab. That's intentional. We don't use the Trigger tab when we're in continuous trace mode, sort of like having a hamburger without cheese, so we bypass that. Pick Control, and then you set the sample rate right here. There's a pull-down box. You can pull it down. Right now it's set to 5 milliseconds. A millisecond is 1/1000th of a second. In this case, we're taking samples every 5 1/1000ths of a second. At this point, we're now ready to eat the hamburger. We now may click Apply, and we go into the scope display. The first thing you want to do is decide, do you want a white or a black scope background? It's set to black right now, but if you wish to change it, click the white background active switch and it will change. And you're looking at this and probably saying, boy, that's kind of a teeny little scope window surrounded by all those panels. I can barely see anything there. And yes, I agree, by default the scope window is badly overcrowded. But happily, it's easy to fix. You just click the little thumbtack symbols in the corner of each panel, here, here, and here, and that will unpin them, and then the measurement panel will expand and fill the entire space, and that's much better. But don't worry, if you need those tabs, they're still there. You just hover over them to bring them temporarily back into view, and you can see they're right here, here, and here. And if you bring it back into view temporarily and then decide you want it permanently to stay there, you can just repin it back in place. It's up to you. Let me remind you too, if you need to make changes to the scope, just click the Window Shade tool. Notice it's there in the upper corner again. Now we're ready to collect some data. Let's talk about continuous trace operation. The scope is ready and waiting. All we have to do is click the play button. That's our start button there. The scope will start collecting data and it will appear on the screen and start scrolling by. If you want to look at something, click the stop button and that will pause the scope. Now, when you first see it, the data will probably not look quite as nice and neat and the traces won't be separated individually, but you can fix that easily if you just click the Fit Traces to Screen control. Looks like four little corners of a square. That will auto-scale the data and separate the traces, and everything will be nice and neat and easy to read. You can do other things too. You can zoom and scroll. You can just click on the traces and drag them to the right or to the left. You can adjust the horizontal time scale by clicking the up-down arrows, which will expand or contract the traces. And you can zoom in different ways. For example, you can auto-scale, or you can auto-scale and overlap the traces. You can fit them to just the X or the Y axis. You can zoom in on a window where you click and drag over part of a trace and it will zoom it to fill the whole screen. You can zoom on the X and Y direction, or if things really get messed up, click the back arrow to go to the previous view. Practice will show you how all these work. If you want to do some actual numeric measurements, open the recording channel panel and repin it, and then hover over the trace. And if you hover at a certain spot, the current values in that location will appear in the recording channel panel, and you can see what the values are at each spot. For example, at this spot, the motor was turning at 487.0136 RPM, and the DC link voltage was about 669 volts. Pretty handy. There are also two measurement cursors on the vertical axis and two on the horizontal. These are good for taking measurements. If you want to take time measurements, the vertical cursors are really good. For example, you want to check a ramp and make sure it took the right amount of time. To use the cursors, click on a trace to select it. Then grab the two cursors up at the top of the screen there, drag them to the right or to the left, position them on the trace. And then if you look over in the measurement cursors panel, you will see the time information that they represent. And a really good box to look at is the difference. That tells you the time difference between those 2 points. In this case, I'm measuring a ramp that is 2009 milliseconds long. That's about 2 seconds. So if that's the time I wanted, I guess my ramp is working. The horizontal cursors measure amplitude. They're right here. And you can look at the vertical values and vertical difference if you wish. And I think now we're probably ready for a lab. We've gulped down that giant hamburger. We're ready to go. We're going to do something a little different in this lab. I'd like you to open your lab manual to Lab 7, but we're not going to go all the way through it. We're going to go only through Step 7 and then stop. You notice there's a little stop sign there in the lab. We stop right before Step 8. So do your lab up to that point, and then of course we'll finish it in the next session. But for now, pause the video, do the lab. All right, well, I hope you enjoyed the scope. It's a fantastic tool, but it's definitely a challenging one to use. You have to be thoroughly awake to use it well. Let's go through a lab walkthrough, and if you had any problems, hopefully my demonstration will clear them up. Okay, well, we're ready to play with the scope. Let me remind you that I have Lab 6-7 loaded up. This is from our previous activity, the keypad lab. I am still plugged in by the USB port on my keypad. I've got a MOVI-Mod flexible here with a DDI CM3C servo motor. We're going to tune it. I'm going to show you how to optimize its behavior using the scope. We've already measured its inertia, but we can adjust the stiffness through the scope. So let's get started. First thing we have to do is open the scope. To do this, I'm going to double-click the top of the axis circle. And then I'm going to go to the More menu and pick Tools and pick Scope. The scope opens up in a separate window, as you can see. Now in this lab, it's going to be a little tricky. I'm going to be juggling back and forth between the MOVI-Suite window and the scope window. Of course, in real life, you'll probably have to do this too if you're using a laptop out in the field. The first thing we have to do is create a new scope project, so we're going to click the Create button. And we're going to select Continuous Trace Mode. Now notice our trace has a default name to it. We could change this if we wish, but it's fine for what we're doing here. Now we need to set up our channels, so we go over here and we change from the Measurement Mode tab to the Recording Channel tab. And you can see we've got a bunch of things already assigned. I don't want to use these. I'm going to clear them all. So I'm going to go here and click the Reset button for each row. And it says, you're deleting something that's connected to a trigger. Is that okay? Absolutely. We're not in triggered capture mode here anyway. All our channels are now blank. I'm going to assign just the first two. To do this, I go out to the little box here and I click this, and it gives me my different choices. Remember, we have different tabs. We have the default selection tab, the master list, and then we can enter by index and subindex. Happily, everything we need for this activity is in the default selection tab. And in fact, the first thing we want is right here, actual speed in system units. So I'm going to pick that and apply it to channel 1. And then for channel 2, I'm going to pick speed set point in system units, which is the second one on my default list. What this is going to show me is what my set point is and what the actual speed is. In theory, they should match, but in real applications, they won't. Tuning helps improve things so that they come to a closer match. Now we skip the trigger layer here because we're not using triggered capture mode, so we go straight to control. And I'm going to change my sample rate from 1 millisecond to 5. That means I take a sample every 5/1000ths of a second. That is fine for what we're doing. We don't have to click calculate or set our post-trigger percentage because again, we're not triggered capture mode. So our hamburger's complete. I can click the apply button. And here's my scope. Remember I told you it looks kind of crowded at first, so we're going to unpin these different panels from around the perimeter so that our measurement window expands to the full size. Let me remind you, if you ever need to get any of those things back, you just go over here and you hover and they pop open again, and you can repin them if necessary, but we're not going to do that at this point. All right, our instructions tell us if the scope is currently running, stop it. And in fact, we can tell, yes, it is currently running because the play button is grayed out and the stop button is white. So I'm going to click stop here, and that'll just halt my scope. Now we need to set up our VFD to start cycling the motor so we can monitor its behavior with the scope. So we go back to the MOVI-C window, and we're going to open the manual mode tool. So we pick manual mode. And we change it to load cycling absolute, and we click activate manual mode. Now we set the first position to 0 and the second to 50. It's already set to that probably from our last activity. We also need to set the speed to the maximum for the motor. In my case, 4,500 RPM matches my motor's nominal speed. I need to click the gear control and I need to reference my drive, so I'm going to click that. And we can hear that little click that tells us it's referenced. I also need to set my acceleration slider to maximum. It already is. Okay, so that's everything we need to do to get the motor ready to cycle. I'll start up the motor by clicking the play button, and it's just going to cycle back and forth endlessly. And now we can go in and start collecting some data. We need to get our scope window back. And I'm going to click the play button to start collecting measurements. So the scope fires up and you can see we're getting data, but it is definitely not scaled very well. It's way off the screen. So I'm going to click the auto scale button right here. And that separates the traces and scales them so they look great. If I want, I can adjust the time setting here and either compress them together or move them further apart. I'm going to move them further apart so we can see them in more detail. Now the blue trace on top is the actual speed of the motor, and it shows it's accelerating up and down and then changing direction. The magenta trace below is the set point. That's what the VFD is commanding the motor to do, and you can see that the two match very well, and that's because my load is just a flywheel. It takes almost no effort at all to tune a motor to handle a flywheel, so we're actually tuned pretty well already. But we're going to play with it anyway just to see what would happen in a real application. Now we need to go back to MOVI-C and make a few changes to kind of detune things a bit. And here's where we have to juggle. So I'm going to try to get both screens aligned in such a way that we can see what's happening, but we can also make some changes. Need to keep my sliders here because I'm going to be playing with them. Now the first thing I'm going to do is set my backlash slider back down to 0%. You would not do this in a real application. You would leave it set to whatever's appropriate. I'm doing this to make the motor misbehave a little bit so you can see what it looks like when it isn't properly tuned. Now I'm going to start messing with the stiffness of the control slider. What this will do is change how stiffly the VFD controls the motor, in other words, how aggressively it tries to maintain the set point. It's set to 1 right now, which is a good moderate setting. I'm going to begin by moving it toward the soft end, bringing it down. All right, let's pause our scope a second. So I press the stop button to pause it, and I'm going to zoom in on one of the traces here by clicking the zoom to window. And you notice here you can see the control isn't quite right. It's a little bit sloppy looking. That is because I've set things too soft. When you're tuning a real application, you look at the actual speed trace, you compare it to the set point trace, and if you notice things like this, you probably want to stiffen up your control system. All right, so let's go back and let's continue collecting data again. So we're resuming operation. We're going to put the slider back to 1. You notice we had a little jerk there. That's because I made that change really quickly, and the scope shows that. But as you can see, we're actually back to fairly good performance at the moment. Now we're going to make things stiffer. We're going to go above 1. And be prepared for this. The motor will do some interesting and kind of noisy things as we get it to a stiffer state. All right, I'm going to stop my scope here so we can look at what happened. First of all, we notice our VFD faulted, and we got a fault code 07.01. That's a DC link fault. What this means is we set our motor to too stiff a control, and it started to oscillate, and then the DC link voltage did some crazy things, and the VFD shut down in self-defense. That is one of the things that can happen when you're tuning if you make it too stiff. Now we can see the oscillation if we zoom in on our traces here. You can see all that jagged activity there. That's oscillation. It means the control system was working too hard to make the motor match the set point, and it pretty much got out of control, oscillated, and the VFD shut down. So that is what happens if your tuning is too tight. Your optimal tuning is going to be somewhere in between too loose and too tight. All right, I'm going to just note down this fault code because we're going to need it in our next lab, so 07.01, and we're going to clear that fault now, get rid of it. And at this point, we've reached the place where we're supposed to stop, so this is where we're going to pick up in our next lab. And that is the end of session 12. We have completed our first scope lab. In our next session, we're going to do a second one. We're going to explore triggered capture mode, also known as single trace mode. See you then.